All right, in this lesson, we're going to talk about linear best fit models. Remember, a linear equation or whatever talks about a straight line, and the best fit part is basically what is a straight line that best fits everything in all of the data in a scatter plot. So one of the things that you have to look at when you're looking at a scatter plot is to look to see if there's certain data points that are grouped together more closely grouped in one part of the equation than another. That's called clustering. Okay, and clustering helps to identify the possible relationships between the data. All right, something else that we've talked about in the past is outliers. And remember, outliers are data points that are vastly different than the majority of the other data. In other words, outliers are data points that are out there from the rest of the data. Okay, so and which can actually have a pretty good impact on some of the stuff. All right, so let's look at some examples. Okay, so it says here a study is conducted to measure the effects of fatigue and testing speed. So first of all, when we look at the pattern here, we're seeing here that it is a negative correspondence. Okay, so it's a negative correspondence. So the timing speed, the higher the timing speed, the lower the amount of time that's elapsed. Okay. So it's a negative correspondence, okay? Or not correspondence, but correlation. Negative correlation. All right? Any clustering. Okay, so if we look at it, and really this point right in here, that right there, there's a good bit of clustering going on there where we have 1, 2, 3, 4, 5, 6, 7 data points that are basically just piled on top of each other. Okay, right between 78 or 79 all the way down to like 53 or so. So identifying a clustering, well, when the time is equal to 10, there's some clustering that's going on right there with your texting speed. After about 10 minutes, your testing speed is about the same for all the people. And any outliers? Well, if you look here, most of this is here except for this one little point up here. Okay, that one little point up there would be an outlier. So there's an outlier at when your time is 35. So apparently there was one person that even after 35 minutes, their texting speed was still way on up there at 90 characters per minute. Okay, so that's how you identify that. All right. Another example of sales of fruit bars are shown in the scatter plot. Describe the pattern, and once again, you see there's a downward correlation or a negative correlation. Okay. All right. Any clustering? Well, let's see here. It looks like there's some clustering, none down here, but it looks like there's some right around in here, right around in this area right there. So somewhere between 75 cents and $1 a bar. Okay. So it would be 0.75 cents to $1 a bar. The fruit sales are sort of clustered together there. Okay. And you notice here that they have this line that's drawn down through. That's called the line of best fit. Okay, and what that is, that's a linear line that sort of goes right through the middle of the data, where you have approximately the same amount of data points below the line as you do above the line. And it's an approximation. Okay, it's not 100% exact. And identify any outliers. Well, let's see. If I look, most of it here, up here though, there's this outlier up here, and that would be at 25 cents a bar. So 0.25. Okay, so there's an outlier there. Okay. One of the things that we look at here, one of the things we can look at is drawing or coming up with an equation for this particular line. And normally we would go y is equal to mx plus b, slope intercept. Okay, so if we look at it, the y-intercept here is at 60 right here. So that would be plus 60. And the slope, it's a negative slope. So it's down 1 and over 2. Okay, so it's a negative 1 and a run of 2. Remember, slope is rise over run. So that would be, the equation would be y equals negative 1/2 x plus 60. Okay, that would be a good equation for that line of best fit. All right. Now, this says compare the given scatter plots of data and their lines of best fit and tell which model better fits the data. Well, obviously, remember I had said that the line of best fit, you want to have about the same amount of points above the line as you do below the line. Okay, and you want to have it close together. So graph A here is, looks like there's a few more lines above it, but graph A is better than graph B. Graph B only has 3 lines below it. And you notice here, this line of best fit goes from the middle of the first set of data to the middle of the second set of data. Same thing here, middle of the first set of data to roughly the middle of the second set of data. If we could have moved that up there. Okay, but once again, it's an approximation. So graph A is a better fit, the line of best fit. Okay, this one here, well, you notice they both go through about through about the same number. Here you have 4 below it and 4 or 5 above it. Here you have 4 above it and 5 below it. So it goes right through the middle of the data. But in this case here, the data points are closer to the line of best fit. They're clumped together more closely. So here again, graph A would fit. That line of best fit would be better. Okay. All right. So here it says estimate an equation for the line of best fit and tell what the slope and the y-intercept represent in terms of the data it models. Well, when we do that, basically what we have to do here is we need to extend this line of best fit down, okay, until we find out what the y-intercept is, which is roughly 130, okay? So we remember, if we go y is equal to mx plus b, so this plus b would be plus 30 because that's the y-intercept. Now, what's our slope? Well, if we go, let's see here. Let's go from this point right here to this point right here. So that means we go, the rise is 1, okay? So the rise is up 1, and the run is 1, 2. So there again, our slope is a positive 1/2 x plus 30. So it's y is equal to 1/2 x plus 30. Okay? All right. So that is it for this lesson. Make sure that you copy down this first page here. about the definition of clustering and the information on outliers. Make sure you ask any questions if you have any. We'll talk to y'all later on.